Okay, welcome to the 2014 question C3 on surface geometry. So the US Marshals Museum in America is shown. Okay, the plan of the building when inspired was by the Pentagon star shape on the Marshals badge. Right. So draw the regular pentagon and complete the given plan and elevation of surfaces A and B, and then determine the dihedral angle between A and B. Right, so the scale is 1:500, so 30 meters equals 30,000 millimeters. You got to convert everything into mil. Alright, and then divided by what you call it, 3,000, or sorry, divided by 500. We're going to knock two noughts off it. So two noughts off the scale, so it's 30. There should have been another nought there, sorry. So I'll just repeat that there. 30,000 millimeters. Knock two noughts off it, and then divide 300 by 5, which is 60. So that's 60. Then 6,000 divided by 500. Knock the two noughts off, so that's 12. This is going to be 24, and this is going to be 48 millimeters. Okay, so we're going to get started. We are going to have to draw the pentagon in plan first. So the size is 60 millimeters. Okay, now a lot of students would get a struggle on drawing this pentagon. You'd be surprised about that. Now in surface geometry, just look, if you sit down in the exam and you're unsure on how to draw the shape, just take your set squares out and draw a shape that resembles what's on the question to make it look right. If you find yourself on the day of the exam in that situation. There's no point in getting bogged down on part A and you know how to do parts B, C, and D. Like it's like maths. If you know how to do parts B, C, and D, and you don't know how to do part A, just use it. Pick a number. Use the answer. Well, the likelihood is, if you don't know how to do part A, you probably won't be stuck on part D. Right. So 60 and my compass, so the external angle of a pentagon is 72 degrees, by the way. So 72 degrees. Careful that you don't mark 68. That's a common mistake students make. Now, you can join the diagonals there. Right, so the XY line is touching the apex of the pentagon. So we're going up 12, 24, and then 48. Okay. So there's the points being brought up. So this is surface A. Here's the elevation of surface A. Now surface B, straight up to here. So there's A, there's B, and there's B in plan. So now it just says draw the given plan, okay, of A, B, and C, and draw the elevation of surface A and B. So you don't have to do C yet. Determine the dihedral angle between surfaces A and B. So here's the line of intersection. Is it a true length already? In either view, no, because it's not parallel to the XY line. So I'm going to look perpendicular to the line of intersection to see it as a true length. So I'll take my heights from elevation. Now I'll label the points as well. Okay, A, I'll change them. J, K, K, J, L, L, P, P, and then point Q. Right, so we can take our heights from elevation. Now you don't need to bother using your compass when they're simple heights like 12, 24 then after the 12, and then 48 then afterwards, because it's just all speed. You know the heights, they're simple heights to mark. If you want to use your compass, it's not a bother. So D go, or sorry, not D. Here's Q1, or sorry, P1 rather. P1. L then is at the same height, L1. J is at the height of 12, J1, and then K is at this height here. So K joins to J. J1 joins to L1, J1 joins to P1, L1 joins to K1. Right, so there's the true length of the line of intersection. So we're going to look perpendicular, or sorry, not perpendicular, we're going to look along that line of intersection because it's a true length. Here's our x2, y2 line. So for our second auxiliary, to get our dihedral angle, we're going to take the distances from the x1, y1 line back. We can use a datum line to shorten the amount of distance we need. So compass on the datum. Okay, so compass back to J, lift, find J here, mark it in. Okay, L is the same, so lift with L, mark it in. There we go, same point. Point P, compass on the datum line, bring to P, lift, find P1, follow it along, mark it in there. The same with K now, K on the datum line, bring the compass back to K, lift, mark it in here, and then here's an edge view of the two surfaces, their dihedral angle. Ooh, a little bit inaccurate there for me. So it was, then take your compass, measure the angle, or sorry, not your compass, your protractor, measure the angle, write it in, 150 dihedral angle. That's surface A, that's B. P2, L2, J2, K2. So that's that part done. Now the next one is determine the vertical and horizontal traces of the plane that contains surface B. I love these questions, right? So this is surface B. Now we're going to get an edge view of this surface here. We're going to get an edge view of that surface. Where is my set square? So line LP is horizontal in elevation, so it's a true length in plan. So I'm going to look along line LP because it's going to appear as a point, and the surface will then appear as an edge. So I'm going to look along line LP. X1, Y1 line. I'm going to take my, I'm going to mark in my heights here. So J is at a height of 12 up from the X1, Y1 line. P is at a total height of 36, 12 and 24. Now here's an edge view of surface B. Okay. The X1, Y1 line in no auxiliary elevation is an edge view of the horizontal plane. So if you extend this X1, Y1 line and you extend this edge view of the surface, this is the point view of the HT because it's where the surface intersects the horizontal plane, and the line of intersection appears as a point. So now we're going to project that point view back. So we are here. So here's the HT there. Okay, so there's the HT. Now, okay, we could continue that along there. So we could all the way up to here. Continue our Y line. There's a point view. There's T. And then to find what you call it, the VT, okay, I could draw my line parallel to the HT through point L, then where L hits the XY line, up and across, and then from point L go straight across from L. And where they intersect, join towards T. So this will be the VT. There's the VT there. But that's going, what if there was an awful lot of space? Like what if you hadn't got a lot of space on your sheet for this? Well, what I would do is draw a line in plan parallel to the XY line, find the elevation of the line and look along it because it'll be a true length. So JP is parallel to the XY line, so it's a true length in elevation. You could look along line JP. Okay, you don't need to do this now, we've already done, but I'm just showing you. So look along line JP. I don't have enough room there. Take your distances from your XY line down to plan. So compass on the XY line down to L. Lift, mark it in on L. Then the same with P. There you go. Now, extend on this surface here. Then here's an edge view of the surface. You can extend that on there. And there's point view of the VT. And then just project it back at the same angle. And that's the most robust way of getting it. Right, the dihedral angle between surfaces B and C is 160. Complete the projections of surface C. Right, so here's the line of intersection LP for the angle between B and C. Now, you need to see the line of intersection as a point, and to see the line of intersection as a point, you look along its true length. Now, it's a good thing that the line of intersection is parallel to the XY line in elevation, so it's a true length in plan. So I can look along this already, and I can actually use my auxiliary from my old part of the question. And it says the angle is 160. So I'm going to apply that angle of 160 to it. Okay, and I have two possible ways of doing it. I can go this way, or I could go this way. So I could go 160 this way. Now, somewhere along these two lines is going to be point Q. Now, if we wanted to get point Q in this auxiliary, well, I project it parallel to line LP, because that's where all the points are going. So it has to be, okay, on one of these lines. Now, you got to note to yourself, this is an auxiliary elevation. So you would take the heights for this U from there. Okay, now this is one possible solution for Q. So Q2, 1, or this is a second possible solution, Q2. Alright, now the one you pick has to match this here. This is way too high of a height. Q2 couldn't be the answer, or solution 2 couldn't be the answer. It has to be solution 1. So I'm going to take my compass here, lift, that's the height of it. I'm going to bring Q up, and I'm going to take my compass, mark it in here, and then I can join the points there, and that's the projections of the elevation of surface C. Now, there's the question done, and that was, without a doubt, class. Cheers, thank you, bye bye.